thanks everyone for joining the Game Builder community call here in the Cartesi Discord. This is the December edition, and if you're watching the recording, this is taking place in the Cartesi Discord, as I just mentioned. You should come join us here and join the conversation if you're not in yet. And you can scan this QR code or check out the links in the description. Quick intro, very short on Cartesi for anyone new here, and why on-chain games is something that we're interested in and that some of our community members are working on. Essentially, we provide Cartesi provides app-specific rollups, which gives obviously your app a full CPU. You're not competing for block space. You have more predictability, etc. in the future. So if someone drops an NFT collection, on Ethereum mainnet, that will affect everyone, including your players that want to maybe move on your chessboard. So, app-specific rollups kind of like alleviate that pain and give you way more power. And then the second advantage is this, expressive general purpose execution environment. Cartesi has this RISC-V virtual machine. Essentially, it emulates, an instruction set architecture, sort of the CPU of your computer, or similar to that. And that allows us to boot, operating systems such as Linux, and to essentially run programs that would traditionally run on Linux in a verifiable fashion. So for games, it makes, onboarding much easier because you could run, a physics engine, you could run, kind of games almost out of the box in a verifiable fashion while being able to prove things back to Ethereum or to your network of choice. That was it on Cartesi. Basically, we will have some ecosystem updates, which will touch on some of the things that were developed on Cartesi in the past for the first 15 minutes. Then we will jump into, our amazing guest speaker. Today we have Sylve. Thanks again for joining, Sylve. I'll get to an intro a bit later, but super excited to have you on. And then some discussions, which, as for those who are not new here, we usually blend those kind of with the guest speaker conversation, as those tend to, get extended a little bit. So on ecosystem updates, last month we had the Cartesi Experiment Week, where, a bunch of contributors to Cartesi just stopped working on core infrastructure and decided to just build, whatever they wanted on top of Cartesi. And out of this experiment week came a few games, 6 to be precise, or 6 game-related projects, including Shipped Out and Cryptopolis, which we touched on last month. And my time is... Anyways, last month. But today we're going to focus on Cartesi Werewolf and Arena Mayhem. And we have Stefan, who's going to talk about Cartesi Werewolf. Maybe Stefan, you can get started. I will stop sharing my screen, and then I'll invite Joao after that to present Arena Mayhem briefly as well. Stefan, if floor is yours.
Okay, can you hear me?
Yeah, all good.
Okay, thank you, Max. So Cartesi Werewolf is like a board game, the Werewolf board game. As some of you might have played in the real life, it's very fun to play with family or friends. But have we seen a real decentralized version Werewolf game on blockchain? No, I don't think so, right? So we built this out of fun, and also I think it's a great example for any game developers to take this example as a reference. In the future, they want to build something, have maybe like similar architecture or similar game logic that they can get inspired from how this dApp is built. So the Werewolf game itself is like you have several players playing different game roles, right? To make this game simple, we narrow it down to one moderator who is like the honest host of the game, which verify a lot of things, verify different players' behaviors, and make sure the game goes along smoothly. And the villagers, who's like playing the good side of the game, and the werewolves. The goal of the two parties, the villagers and the werewolves, are trying to eliminate the other party. But there involves some like trust problems, right? How can we play this game on like a completely transparent blockchain, make the move, and make sure the moves can be validated later, but without revealing those moves while the game is moving on. So in this case, we leverage the cryptographic. There, like each player created a pair of private key and public key, and they share with the moderator, who is like a critical role in this game. All the player moves, if necessary, are encrypted with their private key. And only the moderator have the key to decrypt those moves and validate, make sure those moves are valid along the game is moving forward. And at the end of the game, the moderator will reveal all the keys so that all the previous moves made by every player can be validated, because now all the keys are revealed. Anyone that runs a Cartesi machine or this backend of the werewolf dApp are able to replicate the entire game flow, because Cartesi itself is a deterministic VM environment, and that's like the whole design. And also coding this dApp in Python makes it extremely easy to just import a cryptographic library and write a few lines of code, and you're able to encrypt and decrypt those intensive computation takes nothing while they are performed off-chain on a Cartesi machine. And it's not possible, or even it's possible, it would be extremely expensive to perform it entirely on-chain. So yeah, that's like a quick recap and introduction to the Cartesi werewolf. Thank you. Back to you, Max.
Thanks, Stefan. Yeah, I love werewolf. I love playing. I love getting the little girl, funnily enough, and like peeking through my hands and trying to identify some people to kill. So I could imagine I guess bringing it on chain brings in new things to do. I wonder how you can create some of the drama and gossip, through, I guess the messages is like your main way of kind of communicating. So it gets quite interesting. But yeah, no, great. I really appreciate this explainer, Stefan. If anyone has questions, please ask them in the chat. But next we will have Joao present Arena Mayhem. Joao, the floor is yours.
Yeah, cool. Can I share my screen? Actually, I do have a little presentation.
Yes, please do. Yeah.
Okay. There we go. Okay, so Arena Mayhem was one of those dApps built on the Cartesi Experiment Week, right? And the whole idea is that it's a gladiator arena where you can build your own characters and send them to fight against each other. And you can place bets on them and have fun watching and I'm not a good mechanical player, so whenever I try to design a game, I try to design it or to think about games that I won't be terrible at. So just a strategy game where you build your characters is pretty fun for me. So the team that built the dApp during the experiment week was this team right here. Me, Payal, Shaheen, and Hannah. We had a blast doing it, and yeah, let's get into it, right? What's the core concept of the Arena Mayhem? We opted to go dip a little bit into fantasy, right? With gladiators, and we wanted to create an even bigger system with maybe magic or incredible weapons, things like that. But we opted to start slow and just with the gladiators, so we can build as we go and create cool things on top of it. So it's nice because you have all the good things and fun of creating your own character. You feel your proximity with that character, and that's addictive a little bit. But at the same time, you don't play yourself. So the character creation is very important for you to feel like you're part of the game. You don't play yourself because when I was researching a little bit of what kinds of games we could do with Cartesi, I found out that 0-player games are one of the best things. It's one of the great use cases there are, right? So a little bit inspired by Ultra Chess, we decided to create a 0-player game where you could place bets and it's totally verifiable. And we decided some of the good reasons for using Cartesi is that with Cartesi we can do more complex computations. We can do integrations with libraries that would help on the computations of the fights and how the matches go and turn out. And also the tooling that helps us coming from all the time that Web2 existed. Okay, so for the tech, we mostly use Python for the backend with JS and React for the front end. So the game is very lightweight and it can be run on browsers without much effort. Someone could just clone and run the front end with a lot of ease and build on top of it. And the bets and game logic are done with Python inside the Cartesi machine, right, as I said. So we decided to make it agnostic so people could bet any kind of ERC tokens and put in on any VM chain. And this logic, it works. Part of the idea is that we could make this game as simple as it gets, and we can make it more complicated with time. That means if we want to enhance it and create different versions of Arena Mayhem with different complexities, it could be used as tutorials. So the first version that I'm going to show you right now in the demo, it's basically a very fancy rock, paper, scissors, but it could go way more complicated, applying AI concepts or different tech that are on hype right now. So this is the little demo of the game, right? This is the home screen as soon as you start. The first thing, it works in 3 steps. First, you connect your wallet, then you generate your own character, and then you watch the battle simulation. And if you win, you can get a prize for that. So let's connect the wallet. And here is the character creation screen. As you can see, there's a total of 100 points to be distributed among some attributes, which are attack, defense, speed, and health pool. These stats have different meanings, where you can basically create a more offensive linked character, a more defensive linked character, and you can choose his weapon. So you can opt to use swords, axes, or lances, and that's where the rock, paper, scissors part enters that I mentioned, right? Swords have advantages against axes, lances against swords, and axes against lances. So you kind of create a weapon triangle, and we could really improve on that. So the character is created. Let's wait for the battle scene to happen. Okay, so this whole battle was already generated inside the Cartesi machine. And what's happening now, this interface only takes the log and animate the battle. but the result is already decided. There are some complexities and intricacies related to this, which are things like every round there's a difference on the average damage done, defenses are raised or lowered, and some silly things that actually make the result less predictable and more fun to play with. So what's next for Arena Mayhem? There are a few things that we think about doing. As I said, one of the things I really want to do is create different versions of the dApp, some with very simple commands and structure and interactions, just so people can hop in and use it as a learning platform. Some versions could have power-ups and different things. Some could actually integrate NFT tools, different weapons, users being able to interact with their character in different ways, like creating their own animations instead using the prepared ones, and even running an AI model inside the Cartesi machine to generate sprites for the characters is something that would be really interesting to do, right? Different ways of interaction, like tournaments, would also be really fun, and we're kind of thinking about all of that and how that could be good to the Cartesi community as a whole. So that was Arena Mayhem. Thank you.
Thanks, Joao. Super cool. I really want to play this. So yeah, I hope we can get our hands on it soon. All right. I think next is it's time for our amazing guest speaker, Sylve. Sylve, thanks for joining us. Yeah, we met each other in Istanbul at EW Assembly, Autonomous Worlds. This conference that was there. Great conference, to be honest. 2 days, fully packed with a bunch of people building on-chain games. So super relevant for this call as well. And we had some interesting conversations. And Sylve is full of wisdom and full of knowledge. Maybe Sylve, you can give a quick intro on yourself, your background, and maybe how you got into the space, like I guess the crypto blockchain space, and then more specifically on-chain games.
So hi everyone, I'm Sylve. I'm the co-founder of briq, the NFT protocol on Stocknet, and I'm also the co-founder of Dojo, which is the provable game engine running on the Cairo VM. So the objective of Dojo is to help everyone build either on-chain or provable games by providing you with tools and libraries to do this. You have access to ECS pattern for your Cairo contracts. And you also have access to automatic indexing, client bindings. The objective is to get you up and running to build your game very, very easily. And by leveraging Cairo, which is a provable language, it allows you to just build your game in Cairo, and either you execute it on the Cairo VM or anywhere else locally, and you run all the proof, which is very, very aligned to what you folks have been doing at Cartesi. The really cool thing that's happening with on-chain games at the moment is, for the past 4 years, I would say, we've been trying to put as little as possible on the blockchain and just putting, let's say, just the assets or the property. And now the pendulum is swinging back in full force in the opposite direction, and we're just trying to cram absolutely everything on chain. Every single transaction, every single move, every single shot fired in a game should be a transaction run on chain. And while I think it's all well and good, I'm not sure that's the best way of doing things sometimes, which is why I believe that the rollup as a service model, or the just execute off chain and sell on chain and prove on chain, is definitely the way to go. So I think what you guys are building is very aligned with that vision.
Yeah, you're already touching on some topics that we can dive into a bit afterwards, but maybe we can go a bit around. I sent the links, by the way, in the chat if anyone is curious. briq and Dojo, but maybe I'm curious. So you started with briq, right? Like, what's the inception story there?
The inception story was I had been looking at NFTs for a really, really long time. I wrote my master's thesis about NFTs in 2017. A funny story, I met with the CryptoKitties team in Vancouver during my master's, and I naively asked them, "Oh yeah, like, you made a bunch of money. Are you going to issue token? Is there a fundraise going on?" And then they announced that they had raised 20 mil with a 12 mil with Andreessen. So I kind of looked like an idiot. But I had been looking at NFTs for a really, really long time. I worked at Ledger, the hardware wallet company, for 3 years, and it had always been in the back of my mind. And at some point, I left my job, raised some funds, and we were looking for an idea, something to build. And we came back to NFTs, and we realized that, hey, now NFTs are cool. Everyone's using them. There are these ugly PFP monkeys that everyone has. But it turns out that the tech hadn't changed. And that was very surprising. I thought that the big unlock for NFTs would have been something akin to like the AMM model, or sorry about this. I don't know why this thing is turning on. The AMM model or something else. But for NFTs, it wasn't the case. It was the exact same technologies that was being used in 2021 as it was in 2017. It was very incredible to me. So we thought, hey, it's really funny. So is there anything funny that we could do for NFTs that uses the technology in a bit more hardcore mode? And we just thought about the problem of composability, because you have this idea, this promise with NFTs, such as, oh yeah, your Bored Ape, you're going to be able to bring it around with you in all different kind of different games, and it should be seamless, and that's the metaverse, yada, yada, yada. But in practice, this has never happened. And we started understanding like why this couldn't happen, why things were not interoperable, why things were not composable. And the very simple answer is that, well, most things in the real world are just not composable. So there exists a composability system that allows you to build stuff that is natively composable rather than try and cram things together that just don't mix. And it turns out that it does. It's called a construction game, or think about Mega Bloks or Lego or Playmobil. These things are made to interoperate. They're by design interoperable. And we realized that the way that people were building NFTs so far was the exact opposite. They were building very complex, very abstract 3D models. And then all of a sudden, when you want to compose them, it doesn't work because it's not the same file format. Nothing works. So we say, okay, why don't we go back to the basics? Why don't we just have a composability system as the basis of the protocol? So that's how briq works. Briq is an on-chain construction system. You can just build your NFTs. So you have bricks. These are cubes stored on-chain. And you can assemble them any way you want, make any shape that you want. And that thing will live as an NFT. If you disassemble your NFT, you get your bricks back and you can build something else. It works exactly. It's a bit like NFT matter or clay, if you like. So yeah, briq, the NFT building protocol.
Yeah, no, super sick. It's interesting to see now, like looking back, like it was really early, like kind of ahead of its time. And I think, yeah, we're kind of going full circle a bit, like between should I start with a game or should I start with a sandbox? I'm curious, like, can you tell us a bit maybe about your profile picture? Because that is a briq NFT, right?
It is. It was an artist who, I was just looking at the different things that people were building with bricks. And at some point I realized that there's this guy who's building a lot of different ducks with bricks, like a lot of them. And I started to realize that this guy's selling them. Like he is actually using the bricks to build something and then he's selling them. So we built a collection just for him. So these are called the Ducks Everywhere. They're probably one of the most popular like PFP collections on Stocknet. And the artist just said, yeah, I was looking for an idea to build NFTs, and I didn't want to just upload a JPEG. It didn't make much sense. But just playing around with the briq website and the briq builder, I came around the idea of, oh, how about I would just make a whole bunch of ducks? And that's how the idea came to be.
Super cool. Yeah. Yeah, so I'm curious maybe around this topic, like I think there was a talk by the Moving Castles guys, and they were saying like composability around assets is really hard, right? And I think they're focusing on mechanic composability a bit more. Do you think that kind of going with this sandbox, like minimal sort of atomic approach almost, where you're building these like kind of, Legos is the only way to achieve like asset composability, let's say at scale?
I think that anything else has failed. And when I say has failed, I mean failed miserably. You really have no project that have any kind of composability. You could say that the PFP projects are composable because you can put them as a PFP. I mean, that's something that works quite well, and you can change them. But you have very, very, very few projects that actually have achieved any semblance of composability. Even briq right now. Like, one of the reasons we co-created Dojo was to say, okay, we thought that the on-chain games would come sooner, and that you'd be able to like build a car with briqs and tear it apart, build a gun, and continue playing with the exact same thing in all these different games. But they were just taking a lot more time to come around. And I'm very aligned with the Moving Castles team. If you think about it, one of the most composable game assets in the physical world is a deck of 52 cards. Because the deck of 52 cards allows you to play poker, you can play rummy, you can play blackjack, you can play plenty of games. But the very interesting thing about a deck of 52 cards is that it is very simple. You only have 3 identifiers per card: the type, the rank, and the color. And that's it. And this is precisely because these assets are underspecified and very, very minimal, very low fidelity, that it is easy to interpret them. If you think about it, the rules of poker are not written on the back of it's never written on the back of the king of spades that this card is super strong at poker or very bad at rummy. It's the opposite. It's the rule set of a game that references one of these 3 identifiers to build a diegesis on top of them. And that's because they're very simple and very easy to compose that you can build on top. Loot was one of the very first examples of these. You have 8,000 loot bags. They're just words. And then people say, oh, but then I can break them apart because these are 8 sentences. So maybe one sentence is going to become a separate NFT. That's how you had the loot unbundling thing, where you unbundle your loot bag and you can just get your weapon. And I really agree with the Moving Castles people. I think you need to think with composability in mind. You can't do it anywhere else. And I think a lot of the efforts that have been funneled into the space are very misguided. Because you have this idea, and I don't even think that it is something that users really want. It's more that it's flashy. They say, oh yeah, when AAA, a metaverse game for crypto. And I really do not think that chugging 100 animators on a crypto game is going to make it composable at all. You really need to start thinking from first principles here. And I agree with the Moving Castles people. You need to think about composability as your first layer. And you need assets that are fairly low fidelity.
Interesting. Yeah, no, that's it's interesting to think of. And how do you think of so you know, with briq, you kind of have this sandbox, and there's not like really, I mean, there's the base rules, like you could do anything with it, but there's not necessarily like a defined narrative, right? Or like a defined game that you have to follow. It's like very open.
Yep. It definitely was not the purpose. When people come across briq in the beginning, they said, oh, you guys are building Minecraft on chain. We said, no, because building Minecraft on chain is extremely dumb because you already have Minecraft. What's the upside of putting it on chain? What's the reason? And I mean, we're never going to get Call of Duty on chain. We're not going to, or if we get Call of Duty on chain, it's going to be very bad because we have much better alternatives. You really need to lean into the medium. So I like to think as briq as much more similar to Lego, or it's a toy. I don't like to think of briq as a game. So there is no overworld, there is no shared state, there is no map that you can move around. Briq is a protocol to help you build things that are natively composable, and that's its only purpose. And because the briqs are exactly like the deck of 52 cards, completely underspecified, it means that it's very easy to compose. We have a very extensive attribute system where you can say, okay, I'm going to give the attribute 2D to any construction that only has briqs on the 2D plane, so nothing on the Z-axis. And you're able to verify this on chain because the 3D matrix of a briq set of an NFT is stored on chain. And that's very, very different from what was done before. You're able to continuously interpret everything that is being built with briq. That's quite new.
Very nice. So maybe we can transition a little bit into like, do you already see with briq some people building games, and then maybe also like, you know, this starts touching on a bit of Dojo, right? What you're doing there, and yeah.
I've had a couple of people building on top of it, a few experiments, but it's, and I'm talking to the other builders in the chat. It's you've done this. It's pretty difficult, and adding on top of it the requirement to use an asset on which you don't have control or you don't necessarily know how it works is a lot more complicated. Which was one of the reasons that we recently upgraded all the briq contracts to Dojo, which means that anything that is built with Dojo and running on chain can much more easily interpret them because it follows the exact same ECS pattern. So that's a very nice addition, and we are sponsoring the holiday game jam for Dojo. So if any of you want to build on top of briq, we've got some bounties.
Yeah, I saw that. That's awesome. Yeah, maybe we can transition a little bit into Dojo and kind of like how so you mentioned already, like it was kind of prompted from, you know, your experience with briq, but yeah, like what were the sort of design decisions there, and what does the overall stack look like?
The very beginning of Dojo was some of the very early builders in StockNet, and I'm talking about October 21. So the StockNet testnet was released in, I think, July 21. And by October, we already had a handful of builders that were coming around to build on StockNet. And one of the big narratives that people were pushing was on-chain games. Some of the very early settlers on StockNet really wanted to build these. Some of the teams were Realms, for instance, which stemmed from the loot ecosystem. And they always had this grandiose vision of running an eternal strategy game, running fully on-chain. And they initially started from Arbitrum, and then they decided to move over to StockNet because they said, this thing is never going to run on the EVM. We need something different. We had also Cartridge, who had been contributing. Some of these founding members were early contributors and creators of the Dope Wars, which is the reboot of an old like MS-DOS game or TI-84 game. And they wanted to run it on chain, and same thing. They felt constrained on other platforms. So they say, okay, let's give StockNet a shot. And all of us, kind of drudged along for a full year, and we were all very close because, I mean, there were not that many people on StockNet, and we were all running on the exact same problems, and all of us were reinventing the wheel over and over and over again. So we said, why don't we join forces and actually build tools to help us build these games, and we're all going to benefit from it. So Dojo is a fully community-led project. There is it's not a single company that is behind it, and everyone just helps out. So briq contributed, Cartridge contributed massively, Realms contributed massively, and we have, at this point, I think we have about 50 contributors, and it's just been working very well. So the way the stack works is you have three main components. You have the core of Dojo, which are a set of contracts, and language server. So we've extended the Cairo compiler. So Cairo is the native language of StockNet, and it's a provable language. So anything written in Cairo can be compiled into a zero-knowledge proof that uses zero stars. So you have the compiler extension, which means we rely a lot on macros, and it just saves a lot of time in boilerplate code. So you just build your game, and it follows an entity component system pattern, which really helps with composability. Then you have the indexing part called Tori. And what Tori does is, once you deploy something, it will listen to all the events, and you don't need to do indexing yourself. You don't need to listen to whatever is going on chain. Tori is going to take care of that for you. And then you have the last part, which are the client bindings. Once you have the first two components, it's really cool if your players can actually play the game. So we have a bunch of different components here where you can build your game using either React, Phaser, Unity, Bevy, all kinds of different client games. And the objective here is whatever happens on chain gets funneled into the indexing layer and is translated into a game-aware object that you can use inside your game engine. So Dojo is not a graphics engine. It is not Unity. Its purpose is not to replace Unity. Its purpose is to help you build any game that you want in a provable manner. And because it's running on the Cairo VM, it means that you can either execute it locally on your laptop and computer proof, which gets settled on chain, or you build your game and you execute it on layer 3, on a rollup, or on a layer on Stocknet as a layer 2 directly. It's a very, very flexible system.
Yeah, thanks for that explaining. That was very very detailed and very helpful. So yeah, no, that's wild. So you guys are 50 contributors now, and no, I love that trajectory. I think that's really, really cool. So I'm curious, maybe just take a little bit of a step back. You mentioned, for example, that you guys were reinventing the wheel over and over again. Kind of this initial group, and then you decided to join forces. Can you maybe dive into a little bit more what those initial issues were, and what were the steps there, and what how did you guys end up all coming together and stuff? Like, what were
We had known each other for more than a year at this point. We had built collabs together and worked on stuff together, and it really forges great. We forged great friendships. So we were very close, and we had this idea of building a tool chain. And Mod was coming around, Mod.dev, the Solidity on-chain game engine, and we're like, hey, that thing's pretty cool. It looks like it's an interesting pattern. Can we build something that could help us in the same manner on Stocknet using Cairo? And some of the issues that we faced very early on, two of them at the top of my mind. The first one was indexing. Indexing is a hassle, because if you do not have your contracts organized in the correct, the reason everyone's using the ERC20 pattern is because everyone understands the ERC20. And if you follow the standard, everyone will be able to understand what you're doing. Everyone will be able to index you on AMMs, on their front ends. You know how to parse this information. But if you're building your game, well, you might have some logic. You decide to architecture it a certain way, but then another game might have another logic, and another game has another logic. And if you want to have maybe something that integrates these three games, you really need to deep dive into how they work. And we realized that we started to diverge on a lot of these ideas and standards. So we say, okay, if we have the same standard or the same framework, it will make composability a lot easier. And indexing obviously is a direct consequence of this. And another problem was just the DevNet was very slow that we had. So we decided to build our own, which now is one of probably the most used DevNet on Stocknet at the moment. It's called Katana. And Katana is now basically the de facto sequencer for anything Dojo related. So you build your game, you run it on a local instance called Katana, and Katana will eventually become your own thing where you can run your own L3 on a Katana, settle it on a layer 2, settle it off-chain, anything you want.
Interesting. Okay. No, very cool. No, I love this. You mentioned as well that it's a quite community-centric framework, and you're really building it out in the open. Like, what are your tips there, kind of to get community feedback, get people involved, build just a strong community around it?
The fact that it wasn't spearheaded by any particular company really helped there. We very much came from 3 different projects, came together and said, okay, we had this sort of common goal that we want to achieve. And everyone it wasn't just one entity pushing things forward. The second good thing that I think we've done was being extremely open from the get-go. We obviously have some stronger contributors than others, but we always try, like, whenever someone asks a question, to just answer right away. If people are spending time looking at your open source project and trying to better understand how it works, we just made sure that they had the best experience possible. And that meant really, really listening to any kind of feedback that was given. And in order to make sure that we gathered feedback, we organize monthly game jams. So every month we have a 72-hour hackathon where people just build games. And that helps us in two ways. First off, it makes sure that people are able to ship games in 72 hours, because the biggest problem that you get when you build a game is scope creep. You're like, oh yeah, I'm going to build a grandiose vision, and you spend 6 months and nothing works. Versus focusing on delivering something very small makes sure that the builders are delivering on something and they can experience the full end-to-end stack. The objective in 72 hours is to go from zero to a game running in production. And that already is the case. That's already something that can work. But it really helps us understand where the problems are, what kind of issues people are running into. Maybe the doc is not up to date. Maybe they have issues with the nightly version. Maybe they have issues with the indexing that doesn't quite work with the client that they're building. You name it. Having very tight feedback loops is probably the best thing that we have right now. And the fact that 3 of the main projects that contribute to the ecosystem are direct users of Dojo means that we dog food constantly. When briq is the first project to run on production on StockNet using Dojo, and we run into so many issues because we realized that we hadn't thought very well about how authorizations work, how permissions work. Some things didn't quite work for if you want to be more ERC20 or ERC 721 standardized. So we had to tweak a lot of things, and that's only because someone is actually rushing to push things in production, and because it gets incorporated back into the roadmap very quickly.
Interesting. Yeah, no, that's super useful, and I think a lot of this resonates a lot. I think the scope creep topic also is something that when you have this kind of general purpose VM or environment, we can build anything. People have crazy ideas, but then you have this kind of paradox of choice, like where do I start and stuff. So
back in July during a hackathon, we had a team that was just looking for something to do on Dojo. We said, oh, you know what? Try and rebuild chess. And that became the example that we use in the documentation. You rebuild chess end to end. And we realized that there were a lot of issues that they were running into that we didn't think of. And having this very strong example, I think for mod, it's called Emojimon. It really helps. On top of this, I think now that's something that we're going to explore is having more. If you look at the two games that are built using Dojo or around Dojo, one of them is called Orio for Roll Your Own. It's from the Dopers team, and the other one is Loot Survivors. And the very funny thing is these two games were built by completely different teams who didn't talk to each other, and they sort of look alike. It's very terminal based. It's green text and green images, fluorescent images on top of a black screen, and they look a lot alike. And having these open source UIs that you can pick from is a massive unlock, even probably bigger than the smart contract themselves.
Interesting, yeah. I did think that those two teams, coordinated, or that they were, because indeed they look very similar, like the same green and everything.
Yeah, it's ridiculous. We just make constant fun of them for this.
That's amazing. No, this is great. This helps a ton, Sylve. Maybe we can touch a bit on maybe Cairo a bit, right? I think there's not everyone in this call is familiar, and I'm curious about we can touch a bit more as well on your whole view on what should be running on chain, how we prove things instead of verify, or when should we essentially run things on chain. But maybe you can also give a bit of additional color on Cairo and Starknet.
Sure. To the second question of what should be proved, what shouldn't, if you look back at the early Bitcoin talk conversations with Lord Satoshi themselves, they're already mentioning zero knowledge proofs. There's a passage I think says, if we had access to that technology, if zero knowledge proofs were actually usable in production, we could build a much more efficient Bitcoin. It turns out that the tech wasn't usable back then in the early 2010s. Zero knowledge proofs have been a research topic for a long time, more like a solution that was looking for a problem. And one of the very early people who thought of a possible application of these problems was Elie Ben-Sasson from Starkware. Back then, he was a professor at the Technion University and one of the inventors of Starks, which are a type of zero-knowledge proofs that are quantum resistant, don't need trusted setups. I'm not getting into the details of this. And he was part of the Zcash Foundation. You could already see zero-knowledge proofs starting to get into a lot more blockchain. But they were really, the big unlock for all of this was using them for scaling up Ethereum. The problem that you have with Ethereum is it's all well and good, it's the decentralized computer, but it costs an arm and a leg to run anything on it, because you need, in order to make sure that the system is running, you need to recompute the exact same thing on all the nodes on the network. You need to, all the miners need to do the same thing. And that's very costly, that's very expensive. So it would be much better if we could trust a very big computer to do all the complex computation and verify what they're doing. And this is what zero-knowledge proofs allow you to. They allow you to verify in less time than it took to compute a computation that was done. So that's how validity rollups work, such as Starknet, the ZK VMs, Aztec, and stuff like this. So the way it works is, think of it as, on Ethereum right now, it's as if everyone's using their own car on the highway. And that means congestion, and it's not going very fast, and it's very expensive for everyone because everyone is paying for their own gas. With validity rollup, what you can do is, rather than execute every single transaction that every user is doing, you do this off-chain on an alternate network called a layer 2, and you bundle all these actions into a single zero-knowledge proof that says, okay, I'm going to move from T to T+1, state N to N+1, and I will attest to the validity of these changes. And you don't need to rerun the entire computation. So the way it works is everything happened in Starknet, for instance, gets compiled into a proof that is sent on Ethereum to a verifier contract that verifies whatever has happened on Ethereum. And so it's as if we are not using cars anymore, but everyone gets into the bus and we split the bill. So it's faster, we can have a lot more people on the highway, and it's a lot cheaper. And that's the first application of zero-knowledge proofs, like production, I would say, at a massive scale. And Cairo is actually the language that was developed by Starkware to achieve that goal. Starkware was the first company to build layer 2 networks called StarkXs. So they would go around and ask, and their clients were protocols and companies such as Sylve, the fantasy football company, because they had issues. They had way too many users, and it wasn't possible to handle that many NFTs and that much activity on layer 1. It was too expensive. So Starkware was building the smart contracts for them and doing all the complex computation to build the zero-knowledge proofs. And they realized that every new client that they had to redo the computation over and over again. It was very manual. So they wondered, is there a way to do it more in a more streamlined fashion? Could we build a tool to help us build and write these zero-knowledge proofs? And that's how Cairo came to be. Cairo was actually an internal tool that was built by the Starkware team to build these zero-knowledge proofs. So today, they realized that, oh, hey, we can actually use this technology to build an entire blockchain on it, and we can open source the language so that everyone can use it. And that's what Cairo does. So Cairo is the native language of Starknet, but it's also a language that can be used for any kind of purpose. Right now, you can run a Cairo program, execute it, and then verify your proof you're using one of the many different open source provers that are available, meaning that you do not need to use Starknet to use Cairo. Think of Cairo as like another tool, like Rust or JavaScript. And it's something that is quite well made. It's a pretty powerful language, looks like Rust, and allows you to build anything that can be proved. Anything that is executed on the Cairo VM can be proven. And that's honestly pretty cool.
Yeah, no, it's super cool. No, I love that. What's the, so now I guess going to the topic of what should be on-chain, because I guess there's like, it's a bit of semantics as well. Like when we say on-chain games, it's not always the game running fully on-chain, right? Sometimes we're proving things back to the chain. But how do you think of that? How do you think of these concepts?
You mean what should be executed on chain versus what shouldn't?
Yeah, exactly.
Let me break it down just a little bit. So we've made a couple of initiatives in which we combined, for instance, the optimistic rollups with the zero knowledge proofs, right? So we made a poker, for instance. And in poker, we didn't need to generate zero knowledge proofs from the entire match. We just generated it for a couple of stuff like shuffling the deck, so that we could have privacy on the cards and you could fold and do stuff like that. But when someone calls it and you show your hands, you cannot lie about it. So just like we did a balance of what needed a zero knowledge proof and what could stay on an optimistic rollup, some applications we do, we don't even put everything on chain, or we have a protocol in which let's see if people agree on an application level protocol, and if they don't, then we've enforced them to put all the TD bits on chain and actually calculate it in a decentralized form to settle who's done the right thing, right? So I think that's kind of like Max's question in your experience in gaming. So the games you do, they have 100% of the logic always proved in zero knowledges on chain? Or do you find sometimes that there's a design in the middle ground in which people can just agree? If they don't, then you force them to submit a zero knowledge proof or something like?
I like to think of it as, think of World of Warcraft and the way it's architectured. When you're in the overworld in Orgrimmar, you can see all the cool stuff that everyone has. You can see that I have a flame sword or something else. And the game is sharded. So I'm playing with my friends on a particular server. And when we get into a dungeon, then we're not 100,000 players anymore. It's just 5 players, me and my friends. Or maybe I'm playing the dungeon on my own, and it's just me playing on my own. And what we can see here is the idea of executing everything in the shared context doesn't always make sense. It makes sense for the overworld. It makes sense for Orgrimmar. I want to have access to everything and everyone else. But when I'm playing with my friends, then I just need a shard of that state. I don't even need the full state. I just need to be able to interact with my friends. And then whatever happens on the dungeon gets, as you said, rolled back into a proof and settled back to Orgrimmar. I think it really depends on what you're trying to do and where. I'll definitely veer more towards the try to. I think the settlement makes a lot of sense to have on chain. Obviously, I mean that's a proven business model. But execution, I really am not sure. I think it makes a lot more sense to have it off chain and settle back on chain.
Okay, and about the logic of your games, do you always do it in a provable way like in Cairo, or have you experimented with trying to have a protocol in which people get a consensus, kind of like the optimistic model, right? And if they don't, then you force them to submit a zero knowledge proof or something like?
I don't think we're quite there yet in terms of of tech. It's the fun thing with Cairo is that it's very optimized at the moment for proving Starknet as a whole, but it's a little trickier to just prove a single Cairo program. But we're definitely getting there, and the stack is getting more modular. I think I'm not very interested in the decentralized rollup model. I think if you want to have a rollup, you are already trading off security and decentralization for speed. So I'm not sure a middle ground makes a lot of sense. Maybe it does. And we have different sequences available on Starknet. One of them is called Modara, which is built on Substrate, the thing from the Polkadot ecosystem. It's a Rust-based sequencer. And you have different consensus models where you could say, okay, maybe we have 100 nodes that are all managing the same network. And as you said, you can use a whole bunch of tricks with forced inclusion, challenges, saying, okay, I would challenge your proof, and then you actually need to give me a zero-knowledge proof that you've done it. All bunch of ways of doing it. The crux of the argument, in my mind, is do you really need to put things on chain, or can you just roll them up? I'm not even questioning the different models that could be used to roll up the information. I'm questioning the very premise of everything should run on chain on the same shared state.
Yeah, that's a question that we keep asking ourselves, and particularly haven't found a universal answer. And another thing that bounces in my mind from time to time is that even though the Web3 environment is expanding every year, we're still far away from the usage that Web2 successful game has, for instance. So there's a lot of scalability issues and stuff that we're just scratching the surface. Well,
I think we're being very skeuomorphic in the way we're thinking about this. And I think it also stems from the fact that one of the only thing that has found any sort of product market fit in blockchain or any kind of usage is DeFi. And DeFi needs decentralization. DeFi needs a shared state at all time. It's very dangerous for DeFi to be fragmented, to fragment its liquidity. I'm not sure it's the same for games. I think games are working under very different constraints. And I think, based on my experience, that you can always make the assumption that players will always choose speed over decentralization. It doesn't mean that you need to be completely off-chain. It just means that you can, on the speed to decentralization conundrum, you can veer more towards speed than decentralization.
Yeah. Again, depends a bit on the game, right? Because if you have a game like WoW and out of nowhere you get a player that's super strong and has great gear, you want to make sure that he didn't fake it by forging dungeons he's defeated alone and stuff like this, right?
Yep.
It's great food for thought.
Yeah, I guess you have some models where you prove things afterwards and then slash or something, right? Like you have a really good, I don't know, client-side prediction engine or something, and then the user feels like everything is sort of, low latency, and then you prove things later on. I think Sylve also mentioned something like that, where maybe the proving happens, at night or something after the game.
The cool thing with proofs is the execution has already happened, so you can just completely parallelize proofs. You can just say, okay, maybe we'll have like a 1 hour delay. Like we're executing the game and we're proving it later on, and you can patch that, and that means it's a lot less expensive. Or you can do exactly as your friend said, and just you do it optimistically, and then you can challenge people if they're not submitting the proof. The cool thing that you get with proof is when it's proved, it's verified, and you have complete and absolute certainty on the thing. But proofs can be combined as well. That's the very cool thing. So not only are they parallelizable, but you can also put proofs into proofs. That's actually how StarkNet works. The Cairo programs on StarkNet are actually executed on what is called the StarkNet OS, and the StarkNet operating system is built in Cairo. So it's a very fun thing. The whole blockchain uses Cairo and is built using Cairo. And that's actually, so it's not individual Cairo programs that are proved on Ethereum. It's the state changes of the Cairo, of the StarkNet OS program that are proven on Ethereum. And that means that we're already using proof recursion. You're already building one proof into another one. And we're aggregating different proofs because the Starknet is using the same prover for the StarkXs and for StarkNet. So it's like splitting the bill every single time you roll up the proofs.
Interesting.
And then
so what are... Go ahead, Carl.
Go first, Max. Sorry.
No, I was just wondering. So I think, like your ideal end state, right, is like, or the ideal end state in general is like client-side proving, where you could push everything to the client, to the user, but what are the limitations there, and how far are we from that?
I don't think we're very far off. It's to rephrase, it's still very difficult, but we're progressing so fast that I think it's within grasp in like a year. The problem is proving is still expensive. It is computationally expensive. So the dream would be you have a prover running in Wasm that can prove anything that is happening in your browser. So you play a game, and every so often it will generate a proof that settles back on chain, and that's the dream. But until we can, right now, it's a lot easier to do with custom circuits than with a multi-purpose what is called a DSL for a domain-specific language like Cairo or Noir, because there's a bit more overhead. Think of it as the difference like a GPU and a CPU. Like circuits are GPUs, they're specific to one application, but they do it very fast, but they're not very flexible. And CPUs are very flexible, but they're less performant than GPUs. And Cairo is more of a CPU, and circuits are more like GPUs. But the thing is, we're seeing improvements on the proving side that have me optimistic about the fact that we'll be able to prove Cairo completely natively in a browser within a year. So then you'll be able to play the Wolf game, generate a proof of whatever happens there. You don't need to build a single circuit. You don't need to build an application-specific circuit for anything that you're doing. You just need to write your program in Cairo, which is a normal programming language. So you can have your business logic, your game logic, and your proving logic in the exact same language, which is pretty dope.
Wild. Yeah, that's amazing. 1 year that's crazy.
I'm optimistic.
Another thing that, I have another question on a different direction. But when I think about on-chain games, I always try to come up with a future in which you can have less limitations on what can be made. And a major thing, a major blocker for that is latency, right? So blockchains in general, they have high latency, and that's inherent to the protocol that guarantees the security. In the past, there has been a lot of experiments with state channels and other stuff that can make better latency. But then if you have some dispute or anything like that, sometimes there's no good way to know who broke the trust, right? Both parties can be lying or something like this. And then the game needs to roll back into using blockchain or something that's slower for communication. And having a game that can actually roll back to this mode kind of defeats the purpose. So an FPS, for instance, you cannot just roll back to blockchain, because then you cannot just keep playing it at 1 frame per 20 seconds or something like this, right? And there's some approaches that have been coming, like Word Engine, in which they just do this game shard. They say, yeah, we got a couple of nodes here. The logic's running on these nodes, and then you trust on a couple of guys having consensus really fast on what's the game state, and kind of representing the centralized entity in which we have in World of Warcraft and cloud-based games, right? But I'm still struggling on finding something that can give you low latency and decentralization guarantees. I'm not sure how much effort you put on thinking about this, but I'd like to know your thoughts on this subject.
I think the decentralization bit really depends on what you want. If you think about StockX, for instance, StockX is really cool, but it uses it has a single sequencer. So there's a single sequencer managing the entire server game. But at all points, you have something that is called the escape hatch, meaning that all the users at any point in time can say, okay, I'm leaving StockX and I'm going back to L1. They can bridge everything back. So you always have this mechanism. You have other ways of mitigating these sorts of things, such as forced inclusion of transaction. You have other models. The crux of it, I think, is you will always have the trade-off of low latency versus decentralization. And decentralization doesn't necessarily mean that, how to put it? There are different ways of having censorship resistance and decentralization. It doesn't mean it's a spectrum. You can go full blown. Everything has to be run on a blockchain, which is the highest level of decentralization that you can have. Or you can say, okay, you do, as you mentioned with Argus Labs, it's the right way of thinking about these things, and the way we're architecturing it at Dojo is in the same vein. But you could say that, oh yeah, but if you have a shard, then it has less security guarantees, so it's not as decentralized. I would say that it's completely okay. It really depends on what you're trying to do. The overworld, like Ogrimmar, the layer 2, doesn't need to be as fast as a dungeon. It's completely okay. And the security assumptions will change as well. It's more than, so far, the gold standard for decentralization in application was DeFi. And DeFi needs very strong security assumptions and decentralized assumptions, and is fairly okay with with high latency. Just, I would say, fairly okay. But games, they're not okay at all with high latency, but they can do it with decentralization. So the experimentation ground is a lot bigger. And I would love, for instance, to see state channels come back into fashion. I would love for this. This is definitely the way to do it. You're on the layer 2, you challenge someone to a duel, and you say, okay, either we come out in like an hour, or it's a draw. And when we finish the game, we just send back a proof of who has won, and you have a 7-day challenge period where someone can submit another move to prove that they won. It's okay. It's something that was already experimented with on Bitcoin, like a pretty long time ago. But now that we have proofs, I would love for this design model to come back into fashion because it's very efficient, but it requires a bit of rethinking about how we think about blockchain, because we're going to say, oh, it's not decentralized. I think it's okay, because we're not trying to do the same things that we were doing before. We need new models.
Yeah, about the communication particularly, because there are some ways in which people can disagree on the communication, right? Do you think we'll have to resort to something like a reputation system, like traditional centralized games do? Or you think that maybe we can have some breakthrough on that area that allows you to better understand what goes wrong?
You mean communication as a bit like in the state channel, like how the two players communicate or send information back and forth?
I didn't get your move, and the other guy says, no, I sent it, and stuff like this.
Then I think you can mitigate this with incentives. The burden of proof is always on the person who hasn't sent a move. Like if you've sent a move, you like in your and all of them have received it, you say, okay, I'm good to go. But if you're missing a move, you can say, okay, you're the one who's late, and therefore you can, in the context of a state channel, let's say we're playing chess, and I made my move, and you haven't made a move in 3 days, and then I will say, okay, if you don't make a move, the smart contract now says that I can legally roll back the game and say, okay, I was the last one to make a move, and the other person did not, so they forfeited. But that's only because I made the last move. So in terms of communication, we have different ways of using this. We can use WebRTC, local consensus. I'm not too worried about that.
Yeah, I've been spending a bit of my mind on trying to have some solution for real-time games for that, or near real-time games, right?
Yep, and the less amount of people you have, the easier it is to synchronize.
Thanks for your thoughts.
Yeah, no, it's super cool. Good conversation. Blockchain, I think you just unmuted yourself. Might be.
Can you hear me?
Yep.
Yeah, I'm curious what your thoughts are on fog of war and how necessary it is in building on-chain games. Like, do you think there's room for completely perfect knowledge on-chain games? And like, what do you think? Like, what's going to be bigger, like perfect knowledge games or fog of war shielded games?
I think blockchain already has full information games, and the full information game is called DeFi. And one of the consequences of having full information, this is called MEV, because I can look at the moves you're going to make and I can counterattack them. I really like to think of blockchain as a PvP game and MEV as a PvP game. It's sort of like the first autonomous world, I would say. I don't think it's impossible to build games without hidden information, but I think, and I'm very aligned with the tonk.gg team, they're a research team working on bridging the gap between zero-knowledge research and games, of applying zero-knowledge research for gaming affordances. I really love the model that they have. I really love how they think about things. And I think having hidden information definitely, first of all, I think having an encrypted mempool would really help games. And I take this from Bowden from Ethereum, which is an on-chain game. He said, if your game is not complex enough, it's just going to become MEV with extra steps. And I fully agree with this. Like if you have a game where there are financial incentives to use MEV, people will use MEV. Your game is going to get botted out of existence. So already having encrypted mempools can help there. And I think having the ability to hide information just brings a lot more life into the world. Call of Duty would be really boring if we knew where everyone was on the map. So I think having having a lot more work on anonymity will definitely bring a lot more affordances and a lot more life into these different games. For instance, you could have like a leaderboard to play a game for like speedrunning, and everyone is trying to speedrun the same game. But what you settle on chain to be part of the leaderboard is a zero-knowledge proof of your speedrun, not all your moves, because you don't want to reveal this. And that becomes kind of a fun thing where, okay, how does this guy get to 25 seconds? I thought it was impossible, but I'm not sure how he's done it. It also means that you can hide information inside the game. It means that you can, it's just a lot funnier, I think.
For sure. Interesting. Any other questions here? Feel free to drop them in the chat. Still, what would you like, knowing a bit about Cartesi, what would be some sick games that you think people should build?
Look at board games. I think board games are a fantastic model because they're lo-fi. They're not difficult to build because you don't need complex graphics. Look at a game called, I think it's called Tank Wars. There was a fantastic video about a crew of people called People Make Games. Let me find it. And it was a game of treachery. So it looks a little bit like Werewolf. And they made an entire video of a game studio who played this game, and everyone was fighting. It got so bad that they actually had to stop people from playing it because they were starting to like hate each other for it. I'm sending it on the chat. I forgot the name of this game. But these sorts of games where most of the gameplay happens in people's brains, and that's where the drama comes from, is super interesting. So look at board games and look at whatever Will Robinson is saying on Twitter. He's a very, very smart dude. And I highly encourage you to look at everything he's saying. He has great recommendations about what type of game can be built on chain. So, and please, for the love of God, stop building RTSs on chain. We have already 25 of them. None of them work. It's boring. Build something better.
All right. Noted. No RTSs. Okay, you touched on something interesting, like the drama and the gossip. So how do we, so, Werewolf, we have, let's say Werewolf, like I enjoy it as well because I'm in a room with my friends and I can read their faces, right? And I can see like, okay, who looks suspicious, how do you replicate something like that? How do you bring that drama, on chain? Like, how are you thinking about that?
Very good question. I have no clue.
No clue? Okay. Yeah. I think blockchain, you have a few ideas around that, I guess, with like history, wallet history. Like you could use the blockchain as kind of your guide a bit as well, like based on how people act and stuff. But
I think it's probably easier for this thing to do it off chain. You do it out of bounds. You could be a game as simple as you just need to know who's the imposter. That's it. You just have one function, which is in a single lobby. You have 5 players, and you say, okay, the only thing you can do is select another player and say, he's the one, or she's the imposter. That's the bad guy. And that's it. That's the only thing that happens on chain. Everything else is just a chat and people shouting at each other. And that's it.
Yeah, I guess true. The whole conversation doesn't have to be. Yeah, no, you're right.
Yeah, don't put things on chain when it's not necessary.
For sure. Although I do like the kind of mental model of blockchains as like a truth machine and stuff, and you can go back in time and see what people did and look at their track record and use that as maybe like some input about like how they might be playing the game at the moment, right? But yeah. Anyways, I think I don't know, Sylve, do you have any questions for anyone, for us, or does anyone else have a question? Otherwise, I think that, yeah, Carlo, go ahead.
No, just said it was super interesting. Gave a lot of food for thought.
Mm-hmm.
And yeah, especially this part of making really simple games that on the on-chain point of view, right? So having really basic interaction on a smart contract and let most of the game just flow on a chat or something, like unregulated and wild and free.
Yep. Think of Dungeons and Dragons. It all happens in your head.
For sure.
Just that we have on Web3, we kind of want to put everything in a way that it generates NFT, reputation, other stuff, right? Monetize it, and we kind of forget that we can make games this way if we don't have to gain anything from winning a match or something.
Oh yeah, I mean, that's the thing that really cracks me up with blockchain. If we were to reinvent Wikipedia today, the first thing we would say is, oh, where are the token incentives? Wait, you're telling me that people are going to manage an encyclopedia for free? Oh man, you're very naive. And it works. You don't need token incentives. I mean, when sometimes people ask me on briq, oh yeah, what's the financial incentive of playing briq? Like, there is no incentives. It's like a Lego. Like you're building it, and that's fun, and that's where the value is.
That's true. That's a good, very good point. I think we're also trying to, I mean, specifically around Cartesi, one of the value props is that you can do complex things in a way. So it is an important balance to keep in mind, like, yeah, where to put that complexity, and is it really necessary at all times? Yeah. Anyways, food for thought. This has been absolutely amazing. Sylve, thanks for joining us, and thanks for the great conversation and questions, guys, and thanks everyone for joining. We'll do another one in like a month or so, as usual. In the meantime, enjoy your month of December and maybe your holidays. And we'll talk soon. See you guys.
Cheers, folks.
Okay, guys. Have a nice time.
Cheers. Bye-bye.